My name is Bill Rainey. I am the technical support manager for Basler Electric, as well as the product training manager. If you ever have any questions, feel free to reach out to me. I'll be happy to help you. That being said, I'm going to go ahead and begin the presentation. We will go through a very short presentation as I lead into configuring the DECS with our BESTCOMSPlus software. So first of all, what does DECS actually stand for? DECS is an acronym which stands for Digital Excitation Control System. The products that we're discussing today in this process of the initial configuration can be used on our DECS 150. As you can see here, the DECS 150 on the left, a dual DECS pan. Actually, this is a mounting plate on the right. Also can be used on our DECS 250. Again, the DECS 250 by itself on the left, dual DECS mounting plate on the right. Our DECS 250N, this is actually on the right, showing a cabinet assembly with a dual DECS 250N system. Our DECS 250E. So the DECS 250E combines the controls of our DECS 250 along with a small bridge rectifier inside the assembly as seen on the left, and that assembly can be then either used as a standalone item or packaged as part of a larger cabinet assembly. And then finally our DECS 450. The DECS 450 is used with static excitation systems and comes as part of a cabinet assembly. It will also use a very similar configuration as the DECS 250 family. So all of these products utilize our BESTCOMSPlus software. The BESTCOMSPlus software, we actually developed it back and released it back in 2007. It was part of our introduction of our DGC product line. And every product that we have developed except for the DECS 2100, every product that we've developed since then actually utilized the DECS or the BESTCOMSPlus software. The BESTCOMSPlus software is a shell program which looks much like this when you have the blank shell open. And then you can go up to communication, select new connection, and you can see a list of different products that can be used with. Today I'm going to be communicating with a DECS 250. And I actually have one connected via USB, so I am going to select USB and then connect. As you can see, when it communicates with the DECS 250, it looks much like this. It will open up the software with a metering explorer section along the top portion and the settings explorer section along the bottom portion. Also to note is that the metering portion has the control panel that automatically pops up, and the software is letting us know that it's in live mode by default. If we expand the menu trees for either the metering or the settings explorer, we see further options available. And the division line between those two can be drug around so that you can have one section of the software take up more of your open space than the other. And the same applies to these metering screens. You can drag those around as well. So if I open a metering screen and go to generator primary, for example, but I also want to see the field primary at the same time, I can drag those around and allow them to populate different areas of the screen. If I want to add power, I can add power. So being able to manipulate the metering screens can be very useful whenever trying to view multiple items simultaneously while communicating with your unit. We will come back to the metering screen in just a little while, but to get us started, we're going to actually go up to view and deselect the metering. So our settings portion takes up our entire screen. I also want to note whenever you use the software and you plan to use it for the same purpose, for example, commissioning the DECS 250, maybe you plan to commission DECS 250s on a regular basis, and there are certain screens that you always want to see come up. You can actually set up the software and open the various screens and then save that configuration, both the metering screens and the settings screens, in a what's called a best space file. So if we save that as a workspace, then you can reopen it later, and it will repopulate the software with the way you had left it. So I actually saved one previously for the purpose of this class. So I'm going to open that. And then apply. And then it reopened my metering screens, and then it opened all the setting screens that I had saved as I had saved it previously. So if you utilize that best space option, then that allows you to come through. You can see all the different screens I have open. Allows you to come through and then close them one by one as you address each screen that pops up, so that you're consistent with every screen, which settings that you're addressing. You don't leave something out. And once you have them all closed, then your configuration's pretty much done. So that is one common way for field service engineers to utilize the software. But for the purposes of this class, I'm going to go ahead and close all these screens out so that we can go through the setting of the DECS 250 like you would from scratch. Anytime you're programming a DECS 250, I always recommend that you start by making sure that you know the style of the unit. If you're actually communicating with the unit when you're creating the settings for the unit, then that style will automatically populate. However, it is common for engineers and such to develop a configuration file for a unit before ever actually establishing communications with that unit. If you're going to do so, then again, I always suggest you start with the style number. Make sure that the style number actually matches the unit that you plan to load the file into. You can see here on my screen that the options are all grayed out, and that is because I am communicating with the unit. One thing I failed to mention that's important to note: whenever you are communicating with a unit, the software will state in the bottom right hand corner that it is online. It is possible to have multiple plugins of the software open, and one of them would be communicating with your unit and the other would not be. And in that scenario, if you're making changes to the one that's not communicating, those changes are not going to get saved to the unit. obviously. For example, if I went up to new file, new DECS 250, it opened a new plugin. So I have two tabs open at the top of the software. The second tab, if you look in the bottom right of it, so shows that I'm offline. If I go back to my first tab, we see that that is the one that's actually communicating with the unit and letting me know that it is online. So back to our settings, we can go, we were on the style number. If we then go to device info, this will let us know what the firmware application version is of the unit. It will let us know what the serial number of the unit is. And then we can assign our own custom device ID, maybe based upon the plant that it's located in. One thing to note with the DECS 250 is that it does not have a battery to maintain the clock. So if you remove control power from the unit, you will have to set the clock once again after reapplying control power. The clock setup here is not where you set that time at. This is just the setting up the different settings related to the clock. The actual time would be here in the metering under status and then real-time clock. And this is where you can edit that clock setting. When you first try to make a change to the DECS 250, the username and password by default is simply capital A for each. So I'm going to have it. Okay, so once I close that, my real-time clock is updated. Communications, this is where you would set up your Modbus communication addresses. If you're communicating 480 serial RS485 or Modbus TCP over Ethernet, you would set up your Modbus ID here. System parameters is one of the more important stops as you go through the settings configuration. You definitely want to begin your actual settings with the system parameters, specifically the rated data. So once you go to the rated data screen, it will have an edit option. Once you select that, it will actually pull up the rated data window where you can define what your generator rated voltage is. I'm going to just enter some numbers. And note that it does not allow you to define what the rated current is, or the rated kW is, or the rated kbar. It does allow you to define the rated voltage, frequency, power factor, and kVA. So based upon the rated voltage and rated kVA, and rated power factor, it will calculate what rated kW is and what rated kbars are. So if I hit enter, those will update. So now, based upon my rated kVA, power factor, and voltage, it determined that my rated line current is actually 1000 amp. I'm rated for 5.764 megawatts and 4.323 megabars. We also need to make sure that we set up the rated field data as accurately as possible. The rated values here affect the set points, but it also affects the metering when we're looking at per unitized values. For the purposes of this class, I am just putting some numbers in. Generally, you have a 3 or 4 to 1 ratio between no load and full load. As far as the per unit values, those are going to be based upon the full load values. But the no load values are utilized if you're trying to use the auto tuning, and when it's trying to determine a recommended loop gain, it will use that no load value. So if that no load value is not known, then again, I suggest set it to about 1/4 of the full load value as a ballpark setting. If you are using the DECS 250 or 250N on a brushless excited machine, then you can set up the pole ratio, and there's a pole ratio calculator to determine the ratio, number of poles of your exciter versus the number of poles of your generator, and then it will give you a pole ratio. This number will be used if you plan to use the exciter diode monitor protection option. Rated bus voltage, not necessary unless you plan to perform synchronizing or the sync check functions, but it's generally similar to the rated generator voltage. Operating power input. This is the bridge power input or PMG. Once you have set these, then you can select OK. It will give you some notifications that some of the other settings are going to change based upon that. Again, as I mentioned, these settings do affect the set point ranges for the different modes of operation. So back in system parameters in our settings menu tree, if we go to sensing transformers, this is where we would set up any sensing transformer ratios that we might have. 4160 machine maybe is 4200 for primary and 240 volt secondary. And then this is also where you would define whether you have a 1 amp or 5 amp CT, and then what that primary current is. Again, the bus is not necessary unless you are actually sensing bus voltage. ABC rotation becomes very critical to make sure this phase rotation is set correctly when you are paralleling. If you have that set incorrectly, then you will have paralleling complications. 3-wire delta or C to A for a 2-wire voltage sensing option. 3-phase CT or single-phase B-phase CT. Again, this is DECS 250. Some of these settings are slightly different with the 450. And then moving on, we go to the bridge settings. With the DECS 250, the only option here that you can actually change is the power input configuration, whether you're using like a single phase PMG, or maybe you're using a DC source for the DECS 250 for operating power, or if you're bringing in a 3-phase source for the operating power. Single phase versus 3-phase or versus DC will affect the field forcing capability of the DECS 250. So as we continue on, setting up the data log within report configuration, data log, and data log setup is very important. Oftentimes it's overlooked, but the DECS has the capability of recording these data log events that then can be downloaded and viewed with a different software. We actually have another software on our website labeled Best Wave, or actually our latest version is Best Data. That is the latest version on our website. We just released this past year. And again, all of our software is free to download, but when saving the data logs as ComTrade files from the DECS, then our Best Data software can be used to open and view those ComTrade files. The data logs can also be downloaded as a log file, which you can use software like spreadsheet software to open those log files and graph it out within the spreadsheet software. So the pre-trigger points is how many data points do you want recorded before the actual event occurs, and then the post-trigger is how many will be recorded after the event occurs. If what you're trying to capture a data log on is a start, then obviously you don't really need too many data points recorded before the start. But if you're trying to record on a event like your breaker tripped open, or a loss of excitation condition, or an overexcitation limiter, then you would really need to see what was happening right before the event occurred. By default, there are no pre-triggered points, but we have a total of 1,200 points available. So I'm going to set that to 600. And then my sample interval is the minimum, which only gives me a 5-second total recording. And I would like to have something closer to at least 20 seconds. So I'm going to increase that to at least 16 milliseconds for the sample rate, so that my total recording is about 20 seconds. I want to record the average generator voltage. I also want to see what field voltage is doing, what field current is doing, what generator frequency is doing. And then a lot of times I'll recommend the control output within the list. As you can see, there's a long list of items available to have it record, but we can only record 6 different parameters. So the control output is what the DECS software is trying to do with field voltage. If there's a problem with the power input and the DECS is trying to drive field voltage up, but there is no field voltage being produced, it would let you know, hey, there's a problem with most likely with the power input voltage. And then the final one could be KW, for example, or maybe you want instead of control output, you want K bars, your reactive power. That's how you would set up the data log. Trending, I'm going to skip through that, but that is essentially the same thing. It will record an event, or actually it's recording a duration, and the same 6 parameters can be used. I apologize, I skipped to trigger the data logs. There needs to be something selected. So you can trigger on a start. You can trigger on the OEL or UEL becoming active. There are numerous options for triggering on different modes or different levels. If your voltage got too high or too low, You could trigger on a data log on those events. And there's also logic triggers. But to continue on, we're going to go to operating settings, and then within the operating settings, the DECS 250 can be used on generators or synchronous motors. And so we have that option there. Set point configure will be where you typically enable the autosave. So as you make set point raise and lowers, it will automatically save that as a new set point value. Oops. And then we get to the actual set points themselves. As you can see, I had changed the rated data earlier, and now my set point, my ABR set point, reflects that. So it's now at 4160. Most of the time you set the minimum probably a little tighter than 70%, or perhaps you prefer the 70%. But a lot of applications prefer plus and minus 10%, and those percentage values are going to be based upon that rated voltage value that I previously set. The traverse rate is how fast it will transition from one extreme to the other when you're holding the raise and lower, so you can slow or speed up that transition. And then prepositions are triggered via logic. The preposition logic, once it's triggered, will cause the active mode to go to that particular value for the set point. So if I'm in ABR control and then trigger the preposition, my ABR set point will become whatever I set for the preposition. And there are 3 prepositions available. Field current regulator, this is what, if you were to transition over to manual mode in the DECS 250, you're most likely going to go into FCR control mode. It regulates at a fixed field current level, irregardless of what generator voltage is actually doing. This can be very useful for troubleshooting, and I often recommend starting the DECS when you're first commissioning a unit to start the DECS in FCR control, so that it doesn't worry about what the generator voltage is actually doing. And so if you have a sensing wire disconnected, it's not going to cause any issues if you're in FCR control mode. However, if you're in ABR control, you would end up, if it lost sensing, you might see that your generator voltage climbing up because the ABR is trying to raise the sensing and it doesn't have the ability to sense it. FVR mode, sometimes used for certain testing, but most of the time is not used, especially on a DECS 250 application. If you're using a DECS 250E or a DECS 450 in a static excitation system tied to the main field, and there's a field breaker in place, you might use FVR mode at some point. But again, that is a manual type of mode. It doesn't care what generator voltage is doing while you're in that mode of operation. So we continue, we go to VAR power factor set point. When your generator is online, tied to the utility grid, you may choose to run in VAR or power factor control. And as such, this is where you would set it up. Fine voltage adjustment band, if your voltage actually goes outside of that band based upon the rated voltage, then it will take you automatically out of VAR or power factor control and drop you back into ABR droop. Sometimes if you have a fault out on the line and your voltage starts to, your line voltage, your utility voltage actually drops. you may want to come out of bar or power factor control while that fault has occurred. Power factor active level is how much real power needs to be present on the machine before you allow power factor control to become active. It can be very difficult to uh, determine the precise power factor level if there's hardly any power present. So a lot of applications will leave that at 0%. Some will bump that up to as much as 5% or so. The auxiliary input, this is a bias input where you would bring an analog bias signal, either 4 to 20 milliamp signal or a plus and minus DC voltage signal up to 10 volts to control the DECS. So you can set up to have that bias signal only affect the DECS when it's an AVR control by changing the gain. Again, password and username are capital A. But if the gain is left at 0, then it will have no effect, even if you brought the actual analog signal into the DECS. Parallel line drop. This is where you would enable droop. Typically 3%, maybe as much as 5%. Some applications go beyond that. But droop is one of the more common ways to parallel generators. You would also set up, if you plan to use the DECS 250 or any of the these DECS products, you could set up the network load sharing. And don't really have time to go into too much discussion, but the network load sharing allows the units to share reactive power proportionally between the machines on an islanded system. Essentially, kind of a modern way to do cross current compensation without all of the cost associated with the extra current transformers and conductors and the headaches of balancing CT burdens between machines that a cross current loop introduces. Auto tracking, this we typically recommend having enabled. The auto tracking allows the non-active modes of operation to track what's actually occurring while you're regulating in whichever mode is active. So if you're an AVR control regulating at your nominal voltage and it requires 6 amps of field current, your field FCR control mode will track to that 6 amps of field current. If you then lose the ability to sense voltage or decide to transition from AVR control to FCR control, you could make that transfer and it would be essentially a bumpless transfer. There's actually a null balance LED on the face of the unit to let you know when the non-active modes have tracked to what's actually occurring while you're regulating, to let you know that it is safe to go ahead and transfer if you choose to do so. Startup. So the soft start settings within the DECS allow you to start up excitation and eliminate the overshoot on startup. So analog AVRs will try to go full on when you first start bringing the generator up. Oftentimes, depending upon how fast your machine comes up, your generator voltage can come up and actually exceed your nominal voltage. To help prevent that, we have the soft start settings within the DECS, which slows down that process so it ramps up excitation to bring up your generator voltage more slowly in order to prevent the overshoot. However, I normally recommend having a soft start level set above your residual voltage. So the soft start level is how high the DECS is going to attempt to bring your generator voltage immediately upon a start. And the soft start time is how much time it takes to go from that initial level to 100% of your set point. If your residual voltage is approximately 20% of your nominal voltage, then again, I recommend your soft start setting be at least at 20%. Soft start control, this is if you're using the DECS to control your field flashing circuit. If the DECS is getting operating power from the generator output being shunt powered, then you may need field flashing at some point. And this is where you would define what the percent of rated voltage would be that you want to drop out the field flashing, and then the maximum field flashing time so you don't field flash for too long and cause damage. If you don't reach the field flash dropout level before the time expires, you will end up with a fail to build alarm within the DECS. Gains. So we have some default gains in here. I do not recommend using the default gains. There are custom gains if you know some basic time constants of your exciter and generator. You can select from a list, or you can use this PID calculator, which allows you to enter your generator time constant and your exciter time constant. And then once you do so, it will provide some recommended gain values. Or with these modern DECS products, you can actually use the auto tuning feature. I am going to connect to a different DECS real quick, just so I can show you real quick what that auto tuning looks like. When you perform the auto tuning, you need to be offline. You cannot have your generator actually supporting load or tied to any other source of power. So the generator breaker needs to be open, and the DECS needs to know that. And then you have pole zero cancellation or pole placement as options. And then PMG or external for your power source or shunt powered. Pole zero cancellation is for large machines that are utility tied most commonly. It reduces the overshoot. So when it reduces the aggressiveness of the gains, so you have essentially zero overshoot whenever responding to transients. Pole placement is a more aggressive gain set that will be used on smaller machines most commonly. You begin the auto tuning process, and it will shut off excitation to begin with, and then it will ramp excitation back up, and it will try to get a feel for what the time constants of your exciter is and the time constants of the generator main field are. Once it has developed a feel for those time constants, it will provide a recommendation as far as the gains, and then it will provide those results here on the left. As you can see, it provided some time constants for this machine that this DECS is controlling, and it provides some recommended gain values. So I can then apply those gains and then close out this window. If I then start the DECS, we will see that it will begin regulating. Let me get, that's not the, if we pull up the metering, you can see I'm regulating voltage. Probably being improved upon. I often recommend starting with a Ka value of something very low, such as 0.03. It will, and then if you find that you need a more aggressive response, then go ahead and start bumping that up. So again, most commonly recommend use the auto tuning. It really works, but reduce the Ka value to something very low and then bump it up as you feel you need more of a aggressive response. The Ka value is a loop gain. It's essentially like a multiplier for all of the gains. So as you kind of similar to an analog uh, stability pot on an analog AVR. As you increase it, it's going to get more aggressive. As you decrease it, it'll get less aggressive. We're getting low on time, so I'm going to continue on real quick. But the auto tuning is available for the AVR mode only. There are other gains that we have for the other modes of operation: CR, FBR, the bar, power factor control modes, and the limiters. I actually have my presentation. Here's a recommended group of gains depending upon which type of machine the DECS is being used with. These are recommended as a starting place for your gains, and then again, use the auto tuning for the AVR gains. And if you feel like you need to tweak any of the others, then based upon the response, then go ahead and do so. Limiters are very important, especially the overexcitation limiter within the DECS. You will not have a better piece of protection in place if the DECS can control excitation directly. Then you should rely upon it to limit excitation instead of relying on an external relay to trip off every time you increase excitation beyond certain levels. So you definitely want your external generator protection relays in place. I'm not trying to say don't have protection, but it's important, since the DECS has direct control over excitation, that you set up these overexcitation limiters. Most of the time, there are two options for the overexcitation limiter. You can either choose summing point or takeover style. If you choose a summing point, it'll have a setting screen that looks similar to this. And you want your low level to be above your full load field current threshold. So if your full load field current is 10 amps, you want this set to about maybe 0.5% above that. And then you want to increase your other gains from there as far as the, I'm sorry, I said gains, the other limit levels from there. Going back to my presentation real quick, what we're trying to do with our limiters is keep the generator within this capability curve. So your generator should have a published capability curve. The uh, the D curve, as it's commonly referred to. This upper line here is the overexcitation limit. We need to set the overexcitation limiter within that so that you don't reach that field winding heat limitation of your machine. And that's the main field. This here is your armature winding heat limitation. So if you're producing too much current from the machine, you can basically overcurrent your machine and have the end iron overheating. And then under at the bottom portion, this is where we would set up our under excitation limiter. So you're not reaching the end iron heating for your armature core. And beyond that is the steady state stability limitation. So you definitely don't want to fall out of synchronism between the rotor and your stator. So you set up the UEL to help protect you on this area down here at the bottom. The overexcitation limiter, as I was mentioning, has the summing point style has an offline and an online, and the difference mainly is the fact that the online has an additional level in time. Anytime that the field current exceeds the low level threshold, the OEL is actually active. It will allow you to continue to operate at that level for the duration of the time delay. After the medium time has expired, it will pull excitation current back down to the low level threshold, where it will allow you to continue to operate until something else occurs. Either you decide to trip offline, or maybe the fault goes away. Maybe you can continue to operate on the overexcitation limiter indefinitely, as long as you don't see a problem. As long as load is not changing and you don't run into a protective element that trips you off, then you're fine if the OEL is set up correctly. But if you're hitting the OEL under normal conditions, normal operating conditions, then you probably have a problem somewhere. It might be a problem within the brushless exciter or your slip rings, but typically you don't operate on your OEL very long. You might bump into them occasionally, but it should quickly come off that limiter as you're going through different load transitions. The high current level is an instantaneous cap. If you're above the medium level, then you will, after the high time expires, it will pull excitation down to the medium level for the duration of the medium time. And then there is an integrating reset condition that occurs after you come off or drop excitation below the low level. Because of that field winding heating, you don't want to go immediately back to the starting place. If you exceeded the low level threshold again, you want to go to some advanced period of time based upon how long it's been in reset. So that is essentially the summing point style of OEL. There is also a takeover style, which it reminds me very much of a time over current curve for a protective relay. So again, the low level should always be above whatever your rated full load field current actually is. And it will let you know if there's an invalid setting. And that's another thing. You can actually look in the software under setting validation while you're um, reviewing settings to see if I'm sorry, if there are any settings that are invalid. And then you can also see the range of the settings that you can set by the tab on the left down at the bottom. It will give you that setting range. But as you can see, the takeover style, once you enter values, it looks like an time over current curve, an inverse timing curve, to pull you back down to that low level threshold that you set up. So your limiters need to be coordinated with whatever other protection you have in place. The UEL is the under excitation limiter. I mentioned that in that generator capability curve, you're trying to stay above that under excited limit. So you would define a point where you're producing zero real power, how many bars or K bars your machine can absorb, and then it will create a curve from there. Or you can set up a custom curve where you're defining several different points to create your own curve. But your machine's rated data should have that information as well. Again, it should have a capability curve. You should be able to set that under excited curve based upon that capability curve of the machine. And the rated data that I mentioned earlier, somebody had asked where you would find that. That comes from the OEM. Normally, there's a nameplate that on the machine that has that data. But if not, then hopefully they provided some documentation that has that data. Otherwise, you will have to go back to the OEM to find that information for the rated voltage, rated current, rated power factor, rated kVA, your rated field voltage and current. It's not very common to have the no load, but normally you do find the full load field voltage and field current on the nameplate. Going back to limiters, the last one we're going to worry about is the under frequency limiter. You have a choice of either under frequency limiter or volts per hertz limiter. If you leave it at under frequency limiter, basically, if you're defining a knee point, if your generator frequency is above that knee point, it doesn't affect the DECS operation at all. But once your generator frequency starts to drop, then the DECS will start reducing voltage to help your engine recover. Because the engine is actually what controls your generator frequency, not the DECS. The DECS controls your voltage, it controls excitation, it controls the amount of reactive power being produced by the machine, but it does not control your frequency. It does not control your real power, your kW out of the machine. So the under frequency limiter is just reacting to the fact that your machine is slowing down and your frequency is starting to drop. So it will intentionally reduce voltage based upon your slope so that you're in an attempt to allow your machine to recover faster from whatever load transient occurred. If your machine continues to slow down, then it will continue to reduce voltage, so you're not trying to sit there and produce a higher level of excitation and essentially what some call cook your field. So if your machine is running slower, but you're trying to produce the same amount of voltage and support the same amount of load, then it's going to require more current. And So the DECS will have to produce more excitation even to maintain the same voltage levels that it was before, simply because your machine slowed down. So you don't want to sit there and overheat your field. So we recommend having that under frequency limiter set up, or you can choose the volts per hertz limiter. The difference is that this is always going to be active. You're not defining a knee point. You're just defining the maximum ratio between volts and your frequency on a per unit basis. So you don't want the volts per hertz limiter set to 1.0. Normally 1.05. Maybe you might set the high to 110, and then there's a delay. So it will allow you to get to 110% ratio between voltage and frequency. But after 10 seconds, it will pull you down to the 105%. So that is, if you're rated frequency, then it will allow your voltage to go up as high as 105 per unit, or 1.05 per unit voltage, 105% of your rated voltage. So again, you don't want that at 1.00, because if you're at 1 per unit frequency with a setting of 1.00 for this limiter, it won't allow your generator voltage to go any higher than your rated voltage. Normally you want at least some room to make adjustment 5 or 10% above your rated voltage. So you set this volts per hertz limiter accordingly. And if your frequency starts to reduce, then it reduces your generator voltage, just like the under frequency limiter did. A lot of this we're not going to touch on. PSS, power system stabilizer. Most 250s don't utilize the PSS. DECS 450s, some applications do. That would be a topic, a whole discussion of its own. Same with grid code is more of a European standard. That would be another topic. We're not going to get into that either today. Synchronizer, again, the auto synchronizer can be set up if your unit has the option of the auto synchronizer, but it would be a combination of these settings plus the logic to set up the synchronizer, and that would again be another discussion. Protection. The generator protection within the DECS is most commonly used for alarms or just annunciation. You don't want to necessarily trip the machine offline if you reach one of these one of these protective limits. But some of the more important ones are like the loss of sensing. We do recommend using the loss of sensing. If the DECS loses the ability to sense generator voltage, it can actually let you know that, and you can set it up to transfer to manual. So it transitions over to FCR control and allows you to continue operating, as I mentioned earlier, until something else trips you offline. Maybe you're perfectly fine running at that level until you add load, and suddenly, because you're in manual control mode, if nobody else adjusts excitation, then it would, as you add load, you would see your generator voltage starting to drop. You would have some other protective relay trip you off then, rather than immediately having to trip off simply because the DECS lost the ability to sense voltage. So that can be and commonly is set up to transfer to manual. We do have other over and under voltage protection elements, under and over frequency elements, and power elements that can be set up. Again, most of the real protection is handled by a generator protection relay to perform the tripping of the machine, but these can be set up for annunciation. The exciter diode monitor, I mentioned it earlier. You have to make sure you know the number of poles in the exciter and number of poles in the uh, for the generator, and so you had to develop this pole ratio so that you know the rate of the ripple current. So when DECS is producing excitation, as that energy is being passed on through the exciter, there's a ripple current that rides on top of the excitation that the DECS is producing for these brushless excited generators. And the DECS can measure that ripple current. If that changes, it can detect it either as a shorted diode or an open diode in your brushless exciter and enunciate for that. So that can be set up if you have a brushless exciter and know those values for the number of poles. Configurable protection allows you to select from a list of options to monitor, and then define thresholds for that. This can be used for having the DECS give itself a start or a stop. If it senses your residual voltage or your PMG voltage getting up above a certain level, it knows your machine is started, and it can sense that. You can use this threshold in an overstate and then use this in logic to trigger a start. So that can be done. There's also ways to set up the configurable protection so that you're for synchronous motor applications, so you know when to transition from manual control to automatic control. I apologize, some of these settings, they get a little more involved. We're already beyond the time we had planned, but if you have any questions regarding it, feel free to reach out to me or my group at USA Tech Support at basware.com. Programmable outputs, this is where you would, and programmable inputs, this is just where you're defining labels for your inputs and outputs. So you're not defining what those actually do. And then alarm configuration, this is where you would, most everything is enabled by default, either non-latching or latching alarms. You can go in here and disable things. So that you're not getting a nuisance alarm occurring and taking up a lot of your sequence of event reports and such. For example, the Ethernet link loss, if you don't have or do not plan to use the Ethernet port, you can set that to disabled. And note, every time I make a settings change while I'm in live mode, it automatically will send that or attempt to send that setting change to the DECS. And then finally, we come to our logic. If you expand the logic options here, you just see timers and counters. That's not really where you want to be. You want to actually select the title, Best Logic Plus Programmable Logic. And that's where you will see this page come up. You have multiple logic pages that you can create your logic schemes on any of these first 4 logic pages. This unit has our default logic in it. As you can see, when the DECS is in a started state, it will trigger output 1. If any alarms occur, it's going to trigger output 3. Input 1 is being used to enable the auto mode, and input 2 is being used to enable the manual mode. Raise and lowers are being used for inputs 3 and 4. Those will raise and lower the set points of your active mode of operation. So if you're in AVR control, it'll raise the AVR set point. Prepositions up in the right, we have various those inputs triggering those prepositions. You may choose to have something set up logic to trigger a preposition other than a contact input. This LMJK logic is based upon our DECS 200 design, how those 52LM and 52JK inputs actually operated. So it's our default logic is looking for a B contact from your breakers. So when the breaker is closed, the B contact will actually be open, and vice versa. So once the generator breaker closes, the 52LM input should open, and that will, once that's open, that will enable our paralleling through this NOT gate. So the NOT gate inverts whatever's coming into it. So if this is false, then the output's true. So we will enable the paralleling, we will enable our online OEL, and we will disable our voltage matching. And the combination of both of these inputs being false will end up causing the inputs to this AND gate to both be true. If the AND gate requires all of its inputs to be true in order for its output to become true. So once both inputs are true, then we go into power factor or bar control, whichever one we pre-select. While we're talking about that pre-selection of the bar or power factor control, we need to go back up to this control panel. Again, this DECS 250 design was based upon the older DECS 200 design, and there were some limitations with this design, one of which was this: we didn't have the logic. So we had this setting, bar power factor mode, in the metering of the DECS 200, and we carried that over into the DECS 250. That defaults to being in the off position. I can select a bar or I can select power factor. And as you can see, if I select power factor, the button itself is highlighted, but the corresponding indicator next to it is not. And that indicator next to it won't become active until I am actually in that mode of operation. And I cannot go into that mode of operation unless I'm meeting the logic conditions. So input 8 and 9 need to be false for this logic block to become enabled. I also need to be in a started state. I can't be tied to the utility grid if my DECS is not even in a started state. So if I give the DECS a start, this machine, okay, so the power factor actually changed. This indicator actually became active momentarily, but because my unit is not actually controlling a generator, this particular unit is not, it quickly ended up tripping off and went back to the off mode. So again, that becomes important to make sure you're setting this bar power factor mode selection up properly. If you don't want to have to deal with that in the control panel every time, then you can set up logic to do it. The logic is very simple, drag and drop. So we will go through real quickly setting up that logic to say we want to go into power factor whenever this logic becomes enabled. We always want to be in power factor control. So to set that logic up, we have 3 tabs to choose from down here, and the elements tab is where we'll find that var power factor mode logic element. If we simply want the power factor to be active all the time and the bar and off to be disabled, then we can come back to this IO list and select logic 0. That's a false state all the time. And I can connect that to my off and bar inputs. And then I can come back up and select the logic 1. So this is going to be true all the time. drag that and connect it to the power factor input. So based on this logic, it doesn't matter what I set in the control panel window for power factor mode. This logic is always going to be in control. So once I meet the conditions and enable this element, then it will, because of this logic, go into power factor control. You can set up inputs, or you can set up other logic to control whenever you want to go in the bar, or you prefer to go in the power factor, or you prefer the off. And what the off actually is it essentially is AVR droop, assuming you have droop enabled, and then it would resort to operating in droop while you're parallel to the utility grid. Once I make a logic change, we can see there are 3 indicators on the bottom right. The first one is an amberish yellow because I made a change and I haven't saved it yet. The other 2 are green, letting me know everything's good. But what if something were broken? If I disconnected one of these inputs, just hit delete after selecting that line, it'll disconnect it. Then I see that my logic is broken. This logic diagram status is red, the logic layer status is red, letting me know there's something severely wrong with my logic, and the unit won't be able to accept it this way. If I go to a different page, I can see the 3rd indicator is now green. That lets me know that the logic on this particular logic page is okay. But once I go back to that page that has the problem, then I see that that last indicator is also red again. So again, I scroll down, find where it's at, and then reconnect that. My indicators are green. And then above the logic pages, there's a save bar, or this bar that has some icons, and to the left of those icons is a save option. It's not saving it to the unit, it's not saving it to your computer, it's just saving the logic scheme as part of your open file. So now all my indicators are green. Once I have all 3 of those green, then my unit can accept it. It's important to note that the logic is not saved automatically while I'm in live mode, and it's not saved if I'm just sending settings to the unit. I actually have to come up to communication and then upload logic to device, or upload settings and logic to device. So for now, I'm just going to upload logic to device. Again, I'm logging in capital A for both username and password by default. Then successfully sent all logic. If you don't send the logic, then whatever you create in logic will not be saved in the unit. And again, you have 4 logic pages. You can create whatever you choose on those logic pages. Prepositions is another area where we normally recommend setting up some logic. You would set up a preposition for example, if you do go into power factor control, you can go into this IO list, go to status, and see a long list of different status inputs. So power factor controller becomes active. I can drag that over and I can drop it somewhere on my logic page, and I can delete that line. But if I want to keep input 5 or power factor active, what controls my preposition, then I would need a component, an actual logic gate known as an OR gate. So an OR gate, if any of its inputs become true, then its output becomes true. So if I connect that, then once I'm in power factor control mode, this status input will become active, and then that will trigger the preposition 1. So my pre-positioned setting for power factor control mode will then cause my power factor set point to change to whatever the pre-position value is. So I can save that and then upload that logic to the unit as well. So that is pretty much it for the settings of the DECS products. Again, if there are specific questions, I will look at the questions that come in. But if you continue to have questions regarding setting up the DECS or any of these DECS products, then please feel free to reach out to me or my team. We are always happy to help. Somebody asked, is this going to look similar for the DECS 2100? So as I was mentioning in that presentation, this software is used with our 150, our DECS 150, 250, 250N, 250E, and 450. We also have a DECS 2100, which is even higher end exciter system that goes above the capabilities of the DECS 450 systems. That DECS 2100 software looks similar, but is very different than instead of using BESTCOMSPlus, it uses the software called BESTCOMS Pro. And as such, there is a lot more programmability, a lot more capability of the DECS 2100. And so we are very cautious who we allow actually program those, because there's, again, getting into the DECS 2100, it can be, if you're inexperienced with it, it can be very easy to create problems. Field rated data, is it determined by the generator OEM? Can it be found on the generator manual? Yes. Again, normally you have that field rated data, the full load field rated data on the generator nameplate. It might be typically labeled as exciter field, but it is very uncommon to have the no load values. The no load values might be available if you have a manual that shows, or some testing results of the machine. You might have those no load values, but it's not typically put on the nameplate. And again, the no load values are typically somewhere close to either a third or a fourth of the full load values for voltage, for field voltage and field current. So is the auto tune done speed, no load? Yes, that is correct. It is important to make sure the generator is at rated your nominal speed and you have no load on the machine. As I mentioned, one of the first steps of the auto tuning process is that it shuts off excitation. So you don't want to be supporting load or be tied to another machine while you're doing the auto tuning. The OEL and where to set that really depends on the application. Again, you want the low level limit set above your rated generator field current. However, how high do you set that? Typically about 105% is usually the highest we ever see the low level set to. 105% of your rated field current. And then you might set for the online values, you might set the high level to as high as maybe 165%, with a medium level of about 125%. It all depends on what you're trying to use the machine for, and you need to coordinate it and keep it within the capability curve of your machine. Again, looking at that D curve of the machine, there's the upper portion of that D curve is the field heating limitation. You want to keep it within that field heating limitation, but you don't want to limit excitation too quickly. And so you want it to support faults and feed the fault to help clear the fault. But if the fault is not clearing, then you need to be able to pull back on excitation so you don't overheat your field winding. So that's the intent of the over excitation limiter. We have found that if you set it too low, like high limit of 110%, you may find you're not feeding the fault, and you end up pulling back excitation too quickly and causing your machine to trip off, a loss of field event. And so instead of being able to feed the fault to clear it, you end up tripping off prematurely. And and maybe that's the way you want your machine to set up. Again, that all depends on the application, because if you're supporting load and you're tied to another machine and you start hitting a over excitation limiter, it will reduce excitation, which will your your generator protection is going to see as a loss of field event if you're starting to import reactive power. 105, 125, and 165 for the no for the low level, medium level, and high level comes from one of our field service engineers. We don't really have a white paper on it. IEEE may define some values, or if you're in a region where you have a governing entity that for excitation, they might define some values. In a low transient where the engine slows down, what will be the recommended under frequency slope setting be? The slope setting itself for the under frequency limiter generally is left at 1.0, but if you need it to be a more aggressive ramp reduction in voltage, then you can set it at a higher level. It will reduce, for example, a setting of 2.0 for the slope will reduce the voltage twice the rate of frequency. So if your frequency drops 10%, your voltage will be reduced 20%. Usually with the slope, if some machines actually run at idle speeds, if you need your generator to not be producing voltage while you're at your idle speed, then you would set your slope such that it would reduce the generator voltage as low as possible while you're at that idle speed. And that idle speed on a 60 hertz machine might be somewhere around 45 hertz. So there is a way you can calculate what your slope would need to be in order to reduce generator voltage to essentially zero. There will be some residual voltage on the machine. The DECS won't be able to drive voltage completely to zero. Recently encountered an issue where we were testing an online OEL configured for summing point and stepped into the limit activating OEL. However, when stepping out, the AVR set point would change, but the DECS would remain at the OEL low level limit and not reset. What could be the cause of that issue? I actually recently experienced that issue myself. One thing to recognize, and maybe it pertains to your particular issue and maybe it doesn't, but one thing to recognize is that there is some hysteresis there. So for example, if your OEL low level limit is set to, we'll say 4 amps, and you reduce excitation to 3.9 amps, you may not have dropped below that threshold far enough to allow it to release the limiter. The limiter will remain active in an active state, so that it's not toggling on and off right at that threshold. There is some hysteresis. I don't know how much hysteresis there is offhand, but I know, again, I recently ran into that scenario and I had to either increase my low level limit a little higher or decrease my excitation a little lower to get the OEL to turn off. How do you generate a list of settings to a customer as a PDF for documentation? Good question. If we go into the software, once you create a settings configuration, always save it to your computer. You'll want to go to File and then Save As. It will bring up a pop-up window with file properties. You can add additional information on this pop-up window if you'd like, or you just click OK, and then it'll bring up the next pop-up window, which will allow you to save somewhere on your computer and determine what to actually name the document as. So most of the time, the settings files are named based upon the machine title. So it might be your plant name, unit 2, for example, and you would save the file name as left settings file for that particular machine. And once you select save, it'll save it as this .bst4 file extension. And then you can save that, or you can email that to people, including my team, for evaluation. But if you want to save it as a PDF, it would be that print option that I had mentioned, where you would go through that to save it as a PDF. Can you export the settings to a CSV or XLSX file? Export to file. That's where you would set that to a CSV file. If you need to change the Ethernet settings, it's found up under communication and then configure and then Ethernet. This is where you define or disable the DHCP and then define the IP address, gateway, and subnet. That's again communication at the top, configure, and then Ethernet. If you're updating firmware, you would go up to communication and then upload device files. And it would allow you to locate that firmware package file and then load that into the DECS. Furthermore, with the software, you can actually compare settings files. This can be useful when you're trying to see the difference between one file versus another, and it will bring up a pop-up window that looks like this, and you can, if you have the files, maybe the file is saved on your disk, on your drive, on your computer somewhere, you select settings file on disk, and then maybe a settings file, maybe you have two files, or you can download the settings from the unit, and then it'll allow you to locate that your file that's on your computer, and then you can do a comparison, and it will let you know the differences between those two files, which can be very useful. Somebody asked if the latest firmware is available from the website, and no, it is not. You can send a request to USA Tech Support, and then we can send you that updated firmware file. But we do have to go through an approval process in order to release that. So, but that can be requested from our technical support group. And again, that's USA Tech Support at Basler.com. Appreciate you guys all hanging with me. I know we went rather long today, and if you, again, most definitely reach out to us. My tech support group is continuously answering questions and such. And if you looking for training on our products, we did offer DECS 250 in-house training here at the factory this past year. We will probably be doing that again this upcoming year. We have not set dates yet. Or we can provide custom training at your location if you have a group of engineers that, or technicians or operators that need to be trained on the DECS products. You can feel free to reach out to me about that as well. Again, thank you very much. You guys all have a good day.